In this second video on shapes, we're going to look at some molecules that are a little different. Firstly, we're going to look at ones with double bonds and how we treat those, and then we're going to look at those with coordinate bonds and what we do with those. So, molecules with double bonds. A bonding pair of electrons in a double or triple bond is going to repel in exactly the same way as the bonding pair in a single bond. So we're going to treat the double bond as one bond, one double bond. So although it's two bonds, it's two bonds in one place. This does make it a little bit harder to count up. So at this point, we may need to look at the dot and cross diagram because carbon is in group 4, so it has 4 electrons in its outer shell. Each oxygen is going to give 2 electrons. Each forms a double bond. So it's not, each oxygen doesn't give 1, each oxygen gives 2. Okay, because oxygen needs to form 2 bonds to get from group 6 to a full shell of 8. If you think about the dot and cross diagram, carbon was in group 4. We did draw this dot and cross diagram in our covalent bonding section. Oxygen, each oxygen brings 2. And so, yes, we have 4 pairs around the central atom, and they're all in bonds. There are no lone pairs on the carbon, but there are actually only 2 places where the bonds are. So if there are only 2 places where the bonds are, 2 bond areas, it's like having 2 bond pairs, which we remember is a linear shape, and the bond angle is 180 degrees. Now, to explain this shape, we do actually need to say that there are 4 pairs of electrons around carbon, but they're only arranged in 2 areas. And these electron pairs repel to get as far apart as possible. These bond areas repel to get as far apart as possible, and that gives us the linear shape, 180 degrees. So let's have a look at SO2. So sulfur is in group 6. It has 6 electrons in its outer shell. Each oxygen, also in group 6, needs to get to a full shell of 8, so it gives 2 electrons. It forms a double bond. So if that's true, then of the 6 electrons around the sulfur, we've actually got 2 electrons from each oxygen. So 6 add 2 is 10. That is actually 5 pairs. 4 bond pairs and a lone pair. Why is it 4 bond pairs if there's only 2 oxygens? Because remember, each oxygen forms a double bond. That's 2 bonds. So they're arranged in 2 bond areas, so 2 double bonds and then a lone pair. So we've got 2 bond areas and 1 lone pair. So this is like 2 bond pairs and 1 lone pair shape, which if we remember back, 3 pair shape in total. We're going 1, 2, 3, 1, 2, 3 like that. But we've got double bonds for the sulfurs to oxygen bonds. And then the third pair is a lone pair. I'm just going to tidy this diagram up a bit. So we've got this kind of V shape with a lone pair on top. Bond angle, 117.5, because it's that 3 spreading out areas, 120, but minus 2.5 for the lone pair. If you want to have a think about some others, what about trying the sulfur trioxide? So if you were to try sulfur trioxide, what you would see is, if I was just to add a page in, so if I try sulfur trioxide, sulfur is in group 6. It's got 3 oxygens, each making a double bond. So that is 2 and 2 and 2. Okay, so we're making 3 double bonds. Uses up all 6 of sulfur's electrons to make these double bonds. And so we get 3 double bonds like this. They spread out as if they're 3 bond pairs, even though they're 3 double bond areas. So we get trigonal planar 120 degrees. So it's 6 pairs, but in 3 double bonds, no lone pairs. Now we're going to have a look at some with coordinate bonds and how that changes the shape. So let's do NH3. Just quickly jot down. So nitrogen's in group 5, 3 hydrogens attached and no charge, 8 electrons or 4 pairs. But we can see there's only 3 things, so 3 bond pairs, 1 lone pair. If we learn our shape for 3 bond pairs, 1 lone pair, we get the pyramidal shape. So we're looking like a pyramid. And our bond angle in a pyramid, it's 109.5 minus 2.5 because of the lone pair, so it becomes 107. Now if we do NH4 plus, got nitrogen at group 5, got 4 hydrogens and a plus 1, which means we minus an electron. That's 8 electrons or 4 pairs. But we've got 4 things, so 4 bond pairs and 0 lone pairs. Now the 4 bond pair, 0 lone pair shape is the tetrahedral shape. One of these was a coordinate bond. No lone pairs now, so 109.5 degrees, no reducing by 2.5. So the bond angle increases to 109.5 because lone pairs repel more than the bond pairs do. So when the lone pair is removed, the bond angle loosens up a little bit, increases. Water, oxygen's in group 6, 2 hydrogens, no charge, 8 electrons or 4 pairs. 4 pairs, but only 2 things. So 2 bond pairs, 2 lone pairs. So oxygen has 2 bond pairs and 2 lone pairs. So 4 pairs would be 109.5 minus 2.5 minus 2.5, 104.5. Call that V-shaped. If we do the hydronium ion, we got 6 and 3, minus 1 for the plus 1 charge, 8 electrons or 4 pairs. This time 3 bond pairs and 1 lone pair. So we're going O. In fact, it's going to look very much like the ammonia we drew above. H, H, we've got a lone pair still. We've got a coordinate bond. This whole thing is charged. This is now 107 degrees. It's 109.5 minus 2.5 pyramidal. And then we've got some ions to do as well. So same idea. Nitrogen's in group 5, 2 hydrogens, and a minus 1 charge means add an electron. 8 electrons or 4 pairs. 2 BP, 2 LP. 2 bond pairs, 2 lone pairs. So just like water. V-shaped. 4 pairs is 109.5. So 109.5 minus 2 lots of 2.5 equals 104.5. Call that V-shaped. So our explanation. First of all, what did we work out using the theory? There are 4 pairs of electrons around the central atom. Okay, the central atom being nitrogen. What are they? There are 2 bond pairs and 2 lone pairs. Pairs of electrons. It must say pairs, it can't just say electrons. Pairs of electrons repel to get as far apart as possible. That's the valence shell electron pair repulsion theory. Lone pairs repel more than bond pairs. And that is why that bond angle's been reduced. let's try this one. Aluminium is in group 3. We've got 4 Cls and a minus charge, so we add an extra electron. That's 8 electrons or 4 pairs. We can see that there's 4 Cls, so that's 4 bond pairs, which means we're going to take up the shape of the same shape as ammonia. Let's put that whole thing in a bracket with a minus 109.5 degrees. It's a tetrahedral. There are 4 pairs of electrons around Al. 4 bond pairs and 0 lone pairs. Pairs of electrons repel to get as far apart as possible. We don't actually need to say anything about lone pairs repelling more here because there are no lone pairs.